Today we're going to be learning about sequences and summation notation. You have three objectives. You can see them on your guided notes. We got find particular terms of a sequence from a general term, use factorial notation, and use summation notation. So the first thing we have is the definition of a sequence. And it says it's an infinite sequence is a function whose domain is a set of positive integers. The function's values or terms of the sequence are represented by a1, a2, a3, a4, and then you have the dot 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 to say it goes on until you get to an, and then it can continue on because it's infinite. As soon as we put in a number for a sub n, then we've made it finite, which means it ends. It ends wherever that number is for a sub n. So we have an example 1. It says write the first 4 terms of a sequence whose nth term or general term is given. So let's look at part A for example 1. It says a sub n equals 3n plus 4. So this is its general term. And we want to write the first 4 terms. So that means we are finding a sub 1, a sub 2, a sub 3, and a sub 4. So let's do that. A sub 1 means we're going to plug in 1 for any n. So we have 3 times 1 plus 4. 3 times 1 plus 4, not too hard, 7. And then we have to find the first 4 terms, so we got to do a sub 2. 3 times 2 plus 4. 3 times 2 is 6, plus 4 is 10. And then a sub 3. We got 3 times 3 plus 4. We got 9 plus 4, that's 13. And a sub 4 would be 3 times 4 plus 4. 3 times 4 is 12, plus 4 is 16. And that's part A for example 1. Now let's look at part B for example 1. A little bit harder problem here. Still finding the first 4 terms. And the general term is a sub n equals -1 to the n over 3 to the n minus 1. So again, we're finding the first 4 terms. If we plug in a sub 1, we're going to plug in the 1 anywhere there's an n in our general form, or our general term. So we have -1 to the 1 over 3 to the 1 minus 1. Well, -1 to the 1 is -1. And 3 to the 1 is 3, minus 1, that makes -1/2. Now let's do a sub 2. A sub 2 is -1 squared, because we're now plugging in a 2 for n, 3 squared minus 1. When we square a negative number, anytime you have an even power to a negative number, it becomes positive. So this is positive 1 on top. On bottom, we have 9 minus 1, which would be 1 over 8. A sub 3 would be -1, and now n is 3, over 3 to the 3rd minus 1. We have an odd power to a negative number, that makes it negative, and it'd be -1. 3 cubed is 27, and 27 minus 1 will be -1 over 26. And the last one, I will squeeze in up top here, a sub 4, That's -1. We're plugging in 4 for n. It'll be 3 to the 4th minus 1. And that is -1 to an even power is going to make a +1. 3 to the 4th is 81 minus 1 gives us 1 over 80. Let me get that 80 a little better. 1 over 80. So that's example 1, part B. Now, you guys are going to have to do the checkpoint. You're going to pause right here, and then you're going to work on the checkpoint, show me your work, and I will give you the answers so that you can check your work and make sure you're doing things right. So, checkpoint 1. Checkpoint 1A. The answers are a sub 1. Let's do this. A sub 1 equals 7. A sub 2 come out to 9. A sub 3 is 11. And A sub 4 equals 13. For checkpoint 1B, A sub 1 is -1/3. A sub 2 is 1/5. A sub 3 is -1/9. And A sub 4 is 1/17. Let's move on to the next page on your guided notes. You have factorial notation. And factorial notation says, the definition says, if n is a positive integer, the notation n factorial is the product of all positive integers from n down through 1. So product means you're multiplying. And if we put in a number for n, you would multiply from that number down to 1, all those numbers together. Okay, so we have this general form for n factorial. And it says n factorial equals n times n minus 1 times n minus 2, and so on and so forth until you get to the last 3 numbers they have listed here, which would be 3 times 2 times 1. And the n times n minus 1 times n minus 2, that part looks a little confusing. I understand that. It's probably easier for me to give you an example, and that will show you what factorial means. Let's say my n was 5, and I wanted 5 factorial. Well, what that would mean is we'd take 5 and multiply it down through 1. So it would be 5 times 4 times 3 times 2 times 1. And if we multiply all those out, we get 120. And that's how factorial works. Now, there is one thing about factorial. 0 factorial is equal to 1 always. So let's look at our example 2. And it says, write the first 4 terms of a sequence whose nth term is a sub n equals 2 to the n over n minus 1 factorial. So first 4 terms again means we're doing a sub 1, a sub 2, a sub 3, a sub 4. We're going to plug each of those numbers in and for n and solve them each one. So we got a sub 1 would be plugging in 1 for n. So you got 2 to the first equals 1 minus 1 factorial. 2 to the first is 2. 1 minus 1 is 0 factorial, and we know from the definition that 0 factorial is 1. So that's 2 over 1, which is just 2. A sub 2. Now we're plugging in 2 for n. 2 squared, 2 minus 1, factorial. 2 squared is 4. 2 minus 1 is 1 factorial, and that would be 1 times itself, or just 1, actually, because we count down to 1, so that's 4 over 1, which is still just 4. A3 would be now plugging in a 3 for n, so you have 2 to the third over 3 minus 1 factorial. 2 to the third is 8. 3 minus 1 is 2, so we got 2 factorial, which means we have 2 times 1 on the bottom, which is still just 2. 8 over 2 is also 4. A sub 4, plug in the 4 for n, 2 to the fourth. Make a little better 4 there. 2 to the fourth is going to be, or over top of 4 minus 1 factorial. So 2 to the fourth is 16. 4 minus 1 is 3 factorial, which would mean we're going to have 16 over 3 times 2 times 1, which is 16 over 6. And 16 divided by 6 can reduce to 8/3. Leave it as fractions. Don't give me decimals, please. So, at this point, you are on to checkpoint 2. And you should pause right here, work on checkpoint 2. And then I will show you the answers to checkpoint 2. Make sure you're showing all your work, or you will not get credit for checkpoint 2. So, here are the answers. A sub 1 comes out to 10. A sub 2 comes out to 10/3. A sub 3 is 5/6. And A sub 4 is 1/6. So there's your checkpoint 2 answers. Underneath checkpoint 2, in your guided notes, we have summation notation. Another slide here. Summation notation. And summation has the word sum in it. Right there. Sum means add. That's exactly what we're going to do. And almost looks like Sam, so let's make it look like a sum. Summation. The definition on your guided notes says the sum of the first n terms of a sequence is represented by the summation notation. You have this sigma, looks like an E, a funky E. It's a Greek letter. Sigma, and I'm not very good at drawing it, but it is what it is. And it says I equals 1, and we got an n on top, and it equals, of A sub I, and that would equal all the terms added up from A1, A2, plus A3, plus, and I'm not going to write A4, we'll shorten this up a little bit, dot, 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 all the way to wherever n is. It will stop at A sub n. And this also says where I is the index of the summation. So this little I, that's the index. And that's not always I. It's I in the general form because it stands for index. But you can use different letters. You can use K. In fact, in your example, you'll see we'll have a K. The 1 is called the lower limit. It's the start. It's where you start. We start with, it could be, it doesn't have to be a 1. It is a lot of times, it could be any number, but that's the number you start with. And the upper limit, which is n, is the number you end with. So you got the lower limit, you start with that number. The upper limit, and you got the index, and this little sigma symbol right here, sigma, the E, stands for summation. So let's look at how that works with example 3. Example 3, we got 3 parts here, so you're going to have to squeeze it in probably into your notes. So part A, it says find the summation where the index is 1 and the upper limit is 6 of I squared plus 1. So we're starting at 1 and we're plugging 1 in for I, and we're summing that to plugging in 2 in for I, and then 3 in for I, and 4, all the way to 6. So here's what it looks like. If we start with 1, we would have 1 squared plus 1, and we would add that to the next term, which would be, if we started with 1, we'd go to 2. 2 squared plus 1. And then we'd go to 3 squared plus 1. And then 4 squared plus 1. And then I'm running out of room, so we'll do a 5 squared plus 1, but I don't want it there actually. Need a little more room underneath. So we got a 5 squared plus 1, all the way to 6 squared plus 1. So each one of these, we're going to evaluate each one. So 1 squared is 1 plus 1 is 2. 2 squared, now we're doing 2 squared. 2 squared is 4 plus 1 is 5. 3 squared. 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 15. 5 squared is 25 plus 1 is 26. And the last one, 6 squared is 36 plus 1 is 37. If we add them all up, you're going to get 97. And that's part A, example 3A. Let's look at example 3B. Example 3B, we want the summation, and this time they do change the index letter. It's not I, it's K. It doesn't really mean anything to the problem, doesn't change the problem at all. But we're starting at 4 now, and we're running to 7. And this time we're doing it for negative 2 K, that's a bad K, negative 2 K, or to the K, minus 5. Let's fix my bracket here. So we're starting with 4. Our 4 is where we're going to plug in the K. And we're going to sum them, so we're going to add them. So let's put in the first one, be negative 2 to the 4th minus 5. Plus, next one will be negative 2 to the 5th minus 5. Just count up till we get to 7. And then we got negative 2 to the 6th minus 5. then plus the last one is negative 2 to the 7th minus 5. Let's start figuring these things out. Negative 2 to the 4th, that's 16. Positive 16. And we still got minus 5. We'll do one more step in between. Didn't need a bracket there. Negative 2 to the 5th, that is negative 32 because we got a negative number to an odd power. So negative 32 minus 5. Alright, negative 2 to the 6th. Don't know why I started right. Negative 2. Negative 2 to the 6th is 64. It's a negative number to an even power, so it's positive 64 minus 5. And negative 2 to the 7th is, and this one's going to be negative. A negative number to an odd power, which stays negative. It would be negative 128 minus 5. So each one of these, 16 minus 5 is 11. Negative 32 minus 5 is a negative 37. 64 minus 5 is 59. Plus negative 128 minus 5 is a negative 133. And if we add those up, we get negative 100. There's example 3b. Let's look at example 3c. Example 3c says, find the sum. That's not a sum. Find the sum of 1 to 5. Index of 1, upper limit of 5, of 3. So we're not plugging in I anywhere. There's no I to plug into. Which means the I doesn't affect the term at all, but there still is 5 terms. We still have to go from 1 to 5. So the first term is 3. The second term is also 3. The third term is 3. The fourth term is 3. And the fifth term is 3. So we got 5 threes, which makes 15. So if there's no I to plug into, you just have the number that you have there. And that's the way it works. And there is no checkpoint for example 3. So let's move on to example 4 and see how it works. We're now going from, well, the directions say, express each sum using summation notation. So we're now going from a sum, and we're trying to get the summation notation. Basically, we're going in reverse of what we did in example 3, but they write it out in a little bit easier terms if you're looking at the end of example 3, like 11 plus a negative 37 plus 59 plus a negative 133. We'd be taking a sum like that, and we would come back to the fact that that is B would be negative 2 to the k minus 5 from 4, running from 4 to 7. So we're doing something like that, but the numbers are not that hard. Let's look at the example for A. It says 1 cubed plus 2 cubed plus 3 cubed plus, and we're going to 7 cubed. So what you're looking for is what's changing. It's certainly not the power. The power stays the same each time, and if that's the case, then in our summation, the power is going to be 3. What's changing is what is your variable, and that's going to be your I. And so if we want to write a summation, we're looking at an index equal, and we run from 1 to 7. So The index is 1. We're going to run to 7. And what's changing is these numbers right here. The 1, the 2, the 3, and it would be a 4, a 5, a 6, and a 7. And so that is going to be our variable. That's going to be our I. The 3's aren't changing, so that stays constant every time. So we got I cubed. Summation of 1 to 7 is I cubed. And you could think about, if you actually wrote this out, we would plug in the 1 for I, and you would get 1 cubed. You would get plus, the next number would be 2 cubed. The next number would be 3 cubed. And so on until you get to your end, which is 7 cubed. So we would get the same series. Now, all you need is this part of it. You don't have to rewrite it out. I was just showing you that if we did write it out, we would get the same sum that we did for the summation notation. Now let's look at part B. You have 1 plus a third plus a ninth plus 1/27th plus, and they got the dot dot dot, all the way to 1 over 3 to the n minus 1. And that n minus 1 is all the exponent. And it's running to the nth term. The last one did not run to the nth term. It stopped at 7. And so if it's running to the nth term, our summation has to run to the nth term. So we're going to end at n for our summation. So we got an I here, and it's ending at n. And what's changing each time is not the one on top of each fraction. It is this number right here. And I'll tell you another thing about the nth term. If they give you the nth term, it is a dead giveaway. Dead giveaway for what our summation is going to look like. It is exactly that, except for we're not using n, we're using I. So it's going to be the sum of 1 over 3 to the I minus 1. What's hard about when they give you the nth term is figuring out what number goes here, where we start. Because we know we end at n. We know we end at n. Figuring out what number starts right here. That's what's hard about when they give you the nth term. And so what is on the bottom of this fraction, because this is what's changing, the 3, the 9, the 27. If this number, if the first number had a number here on bottom, it would be a 1. It'd be a 1. And so what we got to think of is, what number could I plug in for I in this sum here that's going to give me a 1 on bottom of this fraction? We already got the 1 on top. That's the one that we have, that's the start of the series, or the summation, is that 1. We got to figure out what we got to plug in here to make a 1 on the bottom of this fraction. And we got this 3 here. And what makes base numbers 3 are powers of 0. And so in order to make this number, whole number on bottom, a 0, I need this I to be a 1. Because 1 minus 1 makes a 0. So that would be what we need I to be. So we would run from 1 to n. Now, it won't always be 1. It is in this example, but that's it. It will be 1 a lot, but it's not always 1. So you have to, now that's our answer. We're done with that. We just had to find the sum. And like I said, when it's in the nth term is given, it's a dead giveaway for the answer. It's just put in an I for the end. You just got to figure out how we start this thing. What number starts at the whole thing. So, your checkpoint 4. You have 2 things to do, A and B. Press pause, work on those, get the 2 sums. I'll give you the answers in just a second. Alright, so the answer for A is the sum of I equals 1 to 9 for I squared. And for B is the sum I equals 1 to n, and this is the one we have the nth term for. It should be 2 to the I minus 1. You will get your homework tomorrow in class to work on. I'll give you the assignment then. Thanks a lot.